Okay. All right. Hello, everyone. Just before we get a few announcements, tomorrow we'll have the We See Social. So you guys should come to that. It'll be a good time. There'll be food. We'll make some stuff. Cyber Tractor Challenge. Richard did this last year. If you have any questions, but John Deere will fly you out. Spend a couple weeks hacking a tractor. It's pretty fun. That application is due March 13th. Lastly, the ICSSP info meeting, which I believe is the
Illinois Cybersecurity Scholars Program.
Yes, yeah, Illinois Cybersecurity Scholars Program. That will be March 2nd, so you guys should show up to that. I believe you could get like a special degree and potentially a scholarship at the university, so it's worth coming to, figuring out what it's about. Yeah, and with that, is that Kevin? We're doing phone four. Let's get into it.
Oh, I only have a meeting challenge, but
My laptop. I don't think.
or the mic. Yeah,
No,
that's fine.
they should be able to hear you from.
Yeah. All right. So yeah. So this is phone 4. When the free is the flag there, and that flowchart there is like the logic inside of glibc malloc as of like a while ago. So as you can see, it's very complicated and this stuff is confusing. And yeah. But we're going to do like a more kind of broad conceptual overview of it. So we won't get into like the nitty-gritty, so it should be kind of less confusing. Yeah, but first, just like review. I've said this like several times before when I give in phone lectures, but just like to give an overview of what phone is. It is binary exploitation, which is you're exploiting generated like compiled code and kind of the kind of the very close to hardware or like close to the operating system things there that are like kind of concealed. Like you peel back the abstraction layer and stuff. And so this stuff is like real stuff. Like this is what a lot of like actual competitive hacking or actual hacking is when you're like, I don't know, like actually selling an exploit to a government or something. It'll usually kind of be this kind of exploit. And even more specifically, when we're talking about heap exploitation, that is like very much the plurality or maybe even the majority of like real world exploits are going to be used after freeze, which is what we'll be learning about today. So also just a brief review of like what memory is. Basically a program has this, you can think of it as just a giant indexable like array, like 1 byte per address. And the addresses are in the range 0 to like 2 to the 64 minus 1. And yeah, the instruction data distinction is not as important today. I'll flip over that. And again, this is the memory layout. Today, we only really care about the heap right there. And this is where dynamically allocated memory is what we can manage. So first, just what is dynamic memory allocation? So far, like when we've looked at programs, right, you've had like maybe a stack allocation where you say, oh, the username is like 30 bytes, for example, 30 characters. And that's fine, but what if, but even then you're like wasting a little space. Like let's say the username is only 5 characters. Now you have like 25 things. And we don't really care when that's only 25 bytes, but let's say you're like uploading a file or something. Now you start caring because like the maximum of files could be like, I don't know, 100 megabytes. But you don't have to allocate 100 megabytes of memory for every file just because it might take up that much space. So dynamic memory allocation allows you to just call a function, malloc, and it will then give you a region of memory that is sized exactly how much you need, or to the nearest 16 bytes, generally. So yeah, this is like a very, very, very commonly used thing in real programs. So the question now is like, what can go wrong? So first, just to understand malloc a little bit more, it allocates, new memory, and there's this region of memory called the heap. I showed you it starts at a given address, and we can call that like address kind of the top of the heap. And then when you call malloc, it'll just allocate some memory right at the top of the heap. It'll like, I don't know, if you malloc 10, where there? Yeah, malloc 10, you'll allocate probably 16 bytes and just return a pointer, a memory address to the top of the heap, and then now the top of the heap has been moved to what was the top of the heap, and now it gets moved down 16 bytes. So you can call malloc a couple times here, and you see we have object A, then object B, and then there's this function called free, which says, I'm done using this memory. And it marks it as like eligible for reuse, essentially. So you can see here, if we free A and then we call malloc again, instead of allocating from the top of the heap, it will instead just reuse the now claimed to be unused region that was previously object A, as you can see there. And so what happens if the programmer accidentally uses memory that has been freed, an address that has been passed as free? And does anyone, okay, like the first 2 lines here, after we've gone through all these memory allocations, we execute that code at the top there. We copy SIGPwny to the memory region, the memory address stored in C, and then we call puts, which prints out the string. So do people know what this is going to print? SIGPwny, right? Because you just copied SIGPwny into it and you're passing the string. Now let's say we write to A though, and remember A was freed, so who knows what A is? But we accidentally, we didn't realize we freed it. We write it to the first character and replace it with a P. Does anyone know what printing out C is going to print after that?
PWN?
Yeah, PWN. Because A is the address. A is just an address, and it's the address at this thing in memory. Object here, it's points here, returns this pointer. Object C, so when you call malloc here, this value, this pointer, this address is the same as this one. And this one is just like supposedly not allowed to, it's not allowed to be used again. It's like undefined behavior if you do. But what's actually happening is that now you have A and C both pointing to the same memory region, and modifications to A will modify C. So that's just the very basic conceptual overview. Once you call free on something, you're claiming that it won't be used again. That memory will be used for something else. But often programmers are really bad at thinking about this sort of stuff, and it does end up getting used again. And so I'm gonna the challenges for today have like a pretty large code base, or pretty large file. It's like a few hundred lines or something. So just to give kind of a conceptual overview, you don't need to read it through and understand all of it. You just kind of need to understand what's going on. And it's a program that allows you to create users and documents. And to start out, there are 2 users, admin and SIGPwny. The goal is to be admin, and when you're admin, you can type shell, and it will give you a shell where you can interact with operating system and read the flag file. And so there are 2 things that are going to be dynamically allocated, 2 types of things, user and document. And so user has a 60-byte name and a 4-byte integer that represents whether it's logged in, because in C, Booleans are just integers. And so that's going to be like 1 or 0, and then name is 60-byte string. And then the document type has a 64-byte text. And something to notice here is that user is 60 plus 4 bytes, 64 bytes, document is 64 bytes. So when you dynamically allocate these things, it'll be like how we're doing the malloc 10. It'll be able to reuse freed chunks, like freed users will become documents, freed documents will later be used as users. So yes, that's an important observation. And now just to get you guys started, this is the bug in heap challenges 0 and 1, or at the very least this is where it's located. Does anyone, I don't know, does anyone kind of have a guess what is wrong in this code?
Do you think you want to, can we go through where you explain the code very briefly?
Sure, yeah. So there's like a bunch of processing stuff, but essentially when you type in the option that is del user, you type in del_user, it will, it does some argument parsing as well in terms of you typed in an ID is the idea for what user you want to delete. And so it first checks if the user is logged in, and all users are going to be logged in generally unless it's the admin. The admin's not logged in. That's why you can't switch to it. This will make more sense when you actually look at the program functionality. But anyway, it then checks if you can't delete the current user, obviously, because that doesn't make sense. You have to switch to another user and then delete one. And then it will just free the memory, the address of the user, which is stored in this users array. And so the bug here is going to be that what you'll notice is even though we called free on this, we never actually modified the users array. We never tracked anywhere that this user ID is now invalid and it's now an empty user. And so, yeah, the issue is this line sort of, but it's more the lack of another line. You might want to set user arg1 to a null pointer or something to mark it as no longer a user. But yeah, so now other operations, like editing a user or just in general, other operations or editing a document, making a document, can possibly retrieve and modify the same memory that this user is, and that is yes, a use after free. So yeah.
Oh, so is there another one that's like add user?
Yeah, there's add user, there's switch user. Yeah.
So if we add a user, then we're able to like get the same region of memory that was free.
Yes, so you can have two users pointing to the same region of memory, although that's not super useful because the same logic applies. But you can also, because documents are the same size, if you create a document, if you free a user and then immediately create a document afterwards, as we saw here, it'll like be this kind of situation where you have this memory region that is marked as free and eligible for reuse. So it'll be reused by the next malloc call, but the user operations are still able to operate on the memory referencing through the user array. And I think it'll make more sense when you guys actually try.
So then modifying the document would modify the user.
Yeah.
Okay.
Yep. So yeah, next meetings, yeah, this Monday, or yeah, we already talked about that. Next Thursday, Richard will be telling you about VM obfuscation and side channels. So that's fun, reversing. And then Sunday is Nathan talking about hacking the DSI web browser, which is very cool. You should definitely go to that. And you should definitely go to Rev 3 as well.
Yeah, come out to Rev 3, guys.
Yeah, that'll be a blast. Yeah, so again, here's the meeting flag. I don't think there's a challenge.
Challenge is up.
Oh, the challenge is up. Go enter it. And yeah, so go through the challenges in the Poem 4 category on cpw20.com. This lecture covered most of the stuff for heap 0 through 2, and then the other stuff kind of combines it with some slightly more in-depth knowledge, not quite to like the flow chart I had at the beginning of the presentation, but you just need to know a little more about implementation, and that's kind of something that's best learned, in my opinion, through suffering. And so you just got to struggle with that for a while if you want to solve those. And you, of course, can ask questions and stuff. But yeah. And also important, don't run the binaries locally to test your stuff because malloc changes quite frequently depending on what glibc version you're using. And so these ones can be solvable purely just through typing into the program through the netcat thing. And you just have to kind of conceptually maybe draw out or think about what is happening with the memory that's being allocated. So yeah, go ahead and try the challenges, I guess. Should I like stop the meeting or should I?
Yeah.
Leave it?
But do you want to do like a walkthrough or something for how to?
Let's get around 15 minutes, then maybe you can do a walk.
No, I mean like just how to run the binaries locally,
Oh well, you shouldn't run the binaries.
or for like patching the.
Oh yeah, honestly, I don't really because I feel like that's that impedes or I feel like it's more important for people to learn the heap stuff than to learn the tooling stuff. The tooling stuff.
Like, how do they learn that if they can't like? Do you just want them to like run it against the server?
Yeah, I mean heap 0 through 2 are totally solvable by just running against the server.
Okay.
I think like if you want to set up tooling for it, yeah, like let me or Richard or somebody know. But it's
a feature, not a bug.
I intentionally omitted.
Is it the like libc though attached to the challenge?
There is a libc attached to the challenge, yeah.
Okay.
So you just want to look at the C file when you're doing at least the first.
I think a walkthrough though would be nice.
Yeah.
There might be a soft script in the GitHub.
Yeah, I can definitely do a walkthrough. I'll let, assuming people are actually doing the challenge. I don't know if but yeah, I'll give it like a few
maybe the
minutes.
walkthrough right now. Is anyone working on the challenge, or does people like, appreciate a walkthrough? Maybe a walkthrough.
Okay, yeah. Are people like generally understanding what's going on?
Oh, you don't want me to walk this stuff on the laptop?
Oh yeah, I can. You have like is this
Yes.
XFCE?
Well, it's not varying to the terminal. So
Should I use console or X? I have Xterm? No, God no.
yeah, hold on, let me. Here. And then let me just.
Oh yeah, and are there slides in Discord? Yeah.
The slides are in Discord, yeah.
All right, yeah, so definitely look at those as you're attempting stuff as well. 'Cause, yeah, you just want to be thinking like what allocations are happening, what memory will this allocation use? Like what allocation?
Do you want this zoomed in more?
You don't want to start.
Okay, you can zoom in and out if you need. I don't know how well you're gonna do this. So,
Oh, I could have tilted that. That would be nice.
okay.
Okay. Yes. Or that's not what it is. I don't remember. Yeah, I'll pull it.
Industry versus industry, like software engineering versus like just CS.
Oh yeah.
It's just so.
Would it be possible to have half the screen console, half the screen in code?
Honestly, the code is not that important for this challenge, so I'm gonna not use the code.
Not important for you or not important for everyone else?
I think honestly, I think for everyone else, it would be more confusing than helpful. That's my opinion. But wait, could someone tell me the URL or the netcat? That's my phone.
CTF.SIGPwny. I don't think that's.
Child.SIGPwny.
I didn't even get it right.
359. Okay, cool. So yeah, heap 0. So this is going to be. I'll just do a quick walkthrough of heap 0. We have all these operations, right? Let's see, you can show users, and we have an admin user and a SIGPwny user. The goal is to be admin, right? Is there like there is a chalkboard. Maybe I should draw this out. So currently we have 2 allocations, right?
Can they see?
Zoom see?
Oh, can Zoom see? Probably not. Well, maybe kind of. Yeah.
I don't know if they can see the camera. Or
Oh, this is the camera.
Recording
Okay.
may not, right?
Yeah, whatever.
This is an extra bonus for those.
Yeah.
True. Yeah.
In-person extra credit. Sure. Okay, so we have an admin allocation. Have one user, name admin. Then we have another thing. So this is like the heap from down. We have SIGPwny. This is awful. That's okay. Yeah, and then okay, so that's our current situation. And current user points to SIGPwny. And now our goal is to get a switch to a user with the name of admin. If we try to switch user to admin, which would be like the naive obvious one, yeah. Okay. Switch user to admin. It's going to tell us it's not logged in, so we can't switch. We need a logged in user that is admin. So what we'll do is we'll create a new user. Seems like a good way to start. And then now we have this new user, Kevin. Now what if we delete this user? Okay. So now what does our heap look like? We have this thing, and it says Kevin on it, but also now it's marked as free. I'm gonna note that. I'll put star. Okay, so this will be used next time we make an allocation. So now, right, we're gonna make a new allocation. We're gonna allocate a document, use create doc. That'll essentially call malloc 64. 64 like the size, the number of bytes to get. Okay, so now we have a document. So this thing is no longer like that. It's now in use and it's a document. So this is a user document. However, the user array, users array contains this, and it still contains this in the index 2. So now the users array contains a thing that the program thinks is a document, or at least can be interacted with as it being a document. And if I do show users now, you'll see that 2 is an empty string, user 2. So now what we can do is we can edit our document, our first document. We can show docs. So this is an empty document, and then we also have a user with an empty name. And if we write doc 0, and if we write, I don't know, like ASDF to it, and then we show docs, obviously, now we see ASDF in it. But if we show users, we also wrote to that. These 2 addresses are the same. So people get how that kind of reallocation happens. So now what we do is we just modify the user or modify the document. So we can write doc 0, we can write admin. And now if we show users, we have an admin user right there that is logged, or well, it's not logged in, but that's fine. We can switch to we got to switch to it first before we write to the document. So let's do that. Create user. I'm going to restart here. Yeah, so we're going to create a user, do the same steps as last time. Create user Kevin. We are going to actually delete it. So user 2. We're going to switch to user 2, and then we're going to create a doc. Write to that document admin, and now we are admin. You can type shell and get the flag. I'm not actually going to cat it because you have to do this yourself if you want to do it. But yeah, and now do that yourself, and hopefully when you do it yourself, you'll gain a better understanding of it. Oh, and also just to update that we ended up editing this document and calling it an admin. Yeah. Any questions?
Will this always work, like no matter what mallet you're using?
This specifically, I would say generally yes, assuming you have just a malloc function, a free function. There are some like allocation things, like I don't know, in the Linux kernel, for example, they'll have different allocation pools for different kinds of objects. So like a task structure might pull from a different set of freed memory than like a, I don't know, a user structure, even though they might be the same size. So there are like, and that's kind of a mitigation against this sort of thing. But however, if it's just a simple like C program that has malloc and free and a single like set of freed things, this should generally work. Yeah. And obviously, this is also dependent on the two kinds of objects being the same size. But yeah, this is all stuff that can be gotten into more later. I guess what time is it? It's only 2:25. Dang, I might have talked too fast or something.
That is supposed to be very young.
I can just talk a lot about the details of glibc malloc if people want eventually, but I'll let people work on the challenges for now.